Hi everyone, welcome back. This is a bonus video for the inventory video series that was done in Unreal Engine 4. We're going to have a look in this bonus video, having a look at how we can set up a inventory system where we can kind of move around items or reorder the inventory as we see fit. Before we get to that stage, just a little discussion on kind of what was covered in the 11 videos prior to this video. We set the inventory up in a way that being able to kind of click and drag and reorder items, we've set it up in a way that that's not going to work straight away. The reason being is that if we have a look in the game instance, which is where we're actually storing the inventory itself, we set this up so that the inventory by default has 0 array elements within it. So it's an completely empty array. In other languages, other programming languages like C#, if you declare, if you want to have a collection of objects, you can either use arrays or lists. With an array in C#, you have to specify what the size of the array is. So if you have 6 slots within your inventory, you'd have to specify the array to have 6 elements to it. If you want to have a dynamically sized collection of objects, you can use lists where you don't have to specify a length, but whenever you add something to that list, it will dynamically grow. In C++, in Unreal Engine 4, that's not the case. There's no differentiation between arrays and lists, and they kind of work the same. I would actually go as far as saying that arrays within Unreal Engine are actually kind of like lists. You can specify, well, actually, they're kind of halfway between. You can specify how many elements you want, or you can specify it as 0 and actually dynamically add to it. Now, because we've set this up as 0, whenever we pick up an item and add it, it basically just adds it to the end of the array. So if we had 0, if we had nothing in the array, we add the first object, it creates index 0, and then we add another object, it creates index 1. The other indices don't actually exist until they are populated. So being able to click and drag and reorder widgets within our inventory is not going to work with the current solution that we have. What we have to do is actually set the inventory up to have the maximum amount of elements so that we can kind of then select and click and drag and move them to where we want. So what we're going to do is inside the game instance, inside the inventory, we're going to have a look at the default values. We're just going to add the amount of array elements equal to what size your inventory is. So mine is 6, so I'm adding 6 array elements. You can see that as we do that, it kind of gives you the default values for each of those array elements. Now, where we kind of differed from the norm here a little bit is that because we're using the data structure, the item data structure, as the actual type of the inventory array, technically the array is never actually empty. If you had done this as an array of objects, you could specify to have 6 elements, but you could specify the object reference to be 0. So you could actually have an inventory of 6 objects, but could actually be empty with no object populating. The way that I've set this up means that we don't actually have that luxury. Even if we haven't picked anything up, the inventory array always has these 6 data structure items that are always there. So what we're going to have to do is basically set up a way to kind of almost like a dummy system of basically saying we'll make a pickup type none, and that will specify there being an empty slot within the data array. So to do that, what we'll do is once we've added those array elements, we'll just compile and save the game instance, and we need to go to our inventory folder and have a look at the pickup type. Now, I've had a few issues with my copy of Unreal Engine. If I try and add or change things in this enumerator asset, it can cause the program to crash, and I think that's probably because the enumeration asset is being used within the construction script of another object. So what we're going to do before we actually tweak that pickup enumerator, we're just going to go to the pickups and the pickup BP. And if you remember from the previous videos, this is where we set up in our construction script how this was going to kind of work for setting up different types of objects. So what we're going to do is, just to play safe, I'm just going to actually just delete this switch on pickup here and just compile that and let it do its thing. That's compiled fine. Let's go and try and tweak the pickup type enumerator now. So what we're going to do is we're going to click new to add a new one, and I'm just going to call this one none. And this will basically specify an empty object within the array. So I'm just going to move none up to the top as well because I want it to be the default one, and we'll just save that. We can close the enumerator off now, and back in the construction script we can just run our switch on pickup type again, and you'll see that none is now the top option there. We're not going to actually plug anything into none because none will specify default values for all of these, which will just be basically empty or nulled. We only need to hook up from the health pack, the ammo, and the coin for this. So we'll leave none as blank. So compile and save that one. So that's the pickup is now done. The next thing to have a look at is the actual logic of the inventory widget itself, in terms of the blueprint stuff. If we just jump into the graph, one thing that you'll remember is when we set this up here, the next thing we'll have to have a look at is the logic within the inventory widget itself in terms of the blueprint stuff in the graph. If we open this up and just jump into the graph, if you remember correctly, when we loop through our visual and data arrays, what we're actually doing is checking to see whether the lengths of the data array and the visual array, if one of them is greater or less than. And that would basically fire off true if the lengths kind of corresponded correctly. If it's set off true, then we'd set the variables of the slot reference for the image, the text, and the current stack. We'd feed the values through from the data array. Now this works nicely for our previous setup of having, starting from 0, then going 1, 2, 3, and so on. That's not going to work well with a stackable, with a reorganizable inventory. So we're going to delete a little bit, but we're going to keep some of this as well. What we're going to do is this comparison here we're going to delete because we don't need that, and we don't need the conditional check either. What we're going to do is we're going to say when we refresh the inventory, we're just going to loop through both arrays and check what's in the inventory, and we'll just basically set each slot to match what's in the inventory, because that way we could have something at index 4 but nothing in indexes 0, 1, 2, or 3, and we basically want to just set whatever is in that item data to match these variables. So we're going to get rid of these ones down here, the sort of the blank ones. We're going to keep these ones up here, which is basically setting the variables of the slot reference. We're going to keep these as they are, and that's pretty much it for that part up here. The next bits to kind of have a look at are any references to where or any uses of the remove index option, because we're not going to be removing indices from the array anymore. As I mentioned earlier, the inventory array is made up of item data structures. It will always be populated with the maximum amount of item data structures. We're just going to set empty slots with the none value to make sure that the slot actually sort of appears empty. It won't feed any of this information through, so the slot will appear empty. So let's just kind of go through each section at a time here. If we just scroll down, the first instance that we're going to have a look at is the toss non-stackable item logic. So previously what we were doing was basically looking at the slot that we clicked and we were just removing the index. Rather than do that, we're going to get rid of this remove index. We're going to use the set array elem node. And we're just going to hook that up into there and that into there. So the slot clicked is still going to be the index, and the inventory is still going to be the target array. What's going to be different this time is that rather than getting rid of the index, we're just going to set the item. So we're just going to use make item data, and we're just going to basically leave all of these as they are. So pickup type will equal none, pickup class will equal nothing, all of these will be empty. And that will basically kind of feed through into the data array and kind of act as almost like a dummy empty index within the inventory array. So that's good for that one. Let's just continue down. So again, any remove index. In fact, actually what we could probably do is maybe just copy paste those two nodes there, because we are going to be reusing them. So Control W just to paste that. Just hook that into there. Slot index goes into the index. Inventory goes into the target array. The make data item data is obviously still hooked up into the item, and just make sure that we're hooking up execution pins, so that can go into there. So that's good for that one. The on-click use button, again, we don't want to remove index. We want to use a set array elem. So set array elem. Hook this back up into refresh inventory and hook this up down to there, and the inventory can go into there. So the slot clicked index is the slot clicked index there. We can hook that up into there, and the item is just going to be the make item data, but we're going to leave it blank. Okay, so that pretty much covers tweaking the inventory. So we can compile that and save that, and let's just close that down. So the next thing to have a look at is the actual pickup logic on the first person character. So if you remember correctly, we set up the actual add to inventory within the first person character. So what we're going to have a look at is this add to inventory here. And we are going to have to add a couple of things here to get this to work the way we want. So we're not going to use the add anymore, because technically the array is already full of item data structures. So rather than adding, we're just going to be using that set array element to change the values, to update the values, kind of similar to what we'd already done up here when we were adding stackable items. We were basically just setting the array element and just updating the array element. We're going to do a very similar thing down here. So we're going to delete that add from there, where we're actually adding it to the inventory, and we're going to use the set array elem again. So we can hook that up into there. We can hook up the inventory into there and the item from here. But before we do hook up the index, we need to think about logically how we're going to check this. We need to check in the inventory where can we insert the picked up item to replace that reference to the non-item. So the idea here is that we'll want to try and put it sort of closer to the start of the array. So we'll want to try and start and put it into element 0, but we'll check if something's in there. If something's in there, we'll put it in into index 1. If there's something in index 1, we'll put it in index 2, and so on and so forth. So to handle this, what we're going to do is we're going to create a new function, which we're just going to call, let's just call it check for free slot. So the free slot function is going to loop through the inventory array, and it's going to try and find the first index where the item data property for the pickup type is set to none. And when we find that, we will set that index to be our free slot index. So we're going to add a for each loop with break. We'll need the game instance and of course the inventory as the array to feed through there. There we go. And what we're going to do is every time this loops through, it's going to look at each array element in turn. So we want to get the item data associated with that index, and we want to check to see if the pickup type is equal to none. Because if it's equal to none, that means that there is no item stored there, so we can add our new item to that index. So from the Boolean conditional, we're just going to run in a branch, and we can hook up the execution there. And what we want to do from this branch, if we find it to be true, we want to set a variable to say that we found the free slot within the array. So we're going to create a local variable for that, which we're just going to call free slot found, and make sure that that is a Boolean. And we can set that Boolean after the true, so just set that to true. And we'll also want a new variable called free slot, which is going to store the actual value, the index value that we found. So we can set that as well. And the actual value we're going to feed in is going to be the array index that we're currently looking at from the for each loop with a break. So once we found that, we don't need to keep running this for each loop. So we can actually hook up the execution from there back into the break. And as usual, just double click on that execution cable just to add some reroute nodes, just so that we can neaten this up a little bit. There we go. Okay, so that looks pretty good. Because we've set this Boolean value to true here, to be able to re-execute this function again without any problems, before we get to the for each loop, we're just going to set this value here to be false, just as a little failsafe, so that whenever we come into this function again, it will set it to false so that we can actually look through the for each loop without it being set to true straight away. So once that's done, from the completed output on the for each loop of break, we're just going to run another branch, and this is just going to handle whether or not we actually found a free slot or not. So we'll need some return nodes here. So I'm just going to right click and add some return nodes, and we need to return a Boolean as an output. And this is just going to be available slot found. So the true will go into the top one and the false will go into the bottom one, but the true return node, we'll just set that to true on the Boolean, so just put the little tick on there. So once that's all done and set up, we can just compile and save, and we can then jump back to the regular event graph. So what we want to do here is, before we set the array element, we just want to grab in this space here, we're just going to type in check for free slot just to call that function. And you can see that we're outputting the available slot. And what we want to do from here is we want to run a branch and just hook up the available slot found into the condition. And if we did find an available slot, we can set the array element. The index is just going to be the free slot variable that we set within this function here. So remember, we set the variable up as a global variable. We're going to set it inside of this this function here, and we're going to use that variable to set the array element. For now, what we'll do, if available slot was not found, we're just going to print a string here, and we're just going to say as a message, no free slots in inventory. And that'll just be a sort of a simple message. You could kind of create a nice little widget, maybe a nice visual pop-up that maybe says no free slots in inventory or something like that. For now, we're just going to print this to the log. So to hook up our original setup from the false, from the start of this function here, from the false, we'll just hook that straight up into there, and from the false here, we'll hook that up into there. So that should add the new object to the inventory in the free slot that we've specified. So just to double check that this actually works and that we haven't completely broken this, let's just compile and save. And if we jump into the game, let's just try picking up an object. So it's still deleting from the game. And if we press the letter I, you can see that we still get our objects in here. So that's great. That's working fine for singular objects. Let's just try pressing some stackable items just to make sure that that's still working fine. And the stackable items are working great. So we can just exit out of that. Jump back into the editor. So that's working great there. So the next thing to have a look at is actually setting up the drag and drop functionality. So what we'll do is we're going to go into the inventory folder here. And what we're going to do is we're going to go onto the slot widget first. Now, one thing that always gets me about Unreal Engine is there's a lot of little options kind of hidden away that if you don't set up properly, they basically can totally break stuff. What I mean in this respect is that to be able to actually enable drag and drop options, there's one tiny little hidden drop down selection that's really hidden away that you need to set. So before we do anything, we're just going to select the slot button here. What we want to do is over in the details, if you have a look in under the interaction section, we want to have a look for this click method. Now generally this is actually hidden away, you can't even see it. It's just so you have to press this little down button here. And click method, it's usually set to down and up, but we want to make sure that we're using precise click. And if we have a look at the little tooltip here, you can see that precise click inside a list, buttons can only be clicked with precise tap. Moving the pointer will scroll the list. It'll also allow drag droppable buttons. But because we want to drag and drop our button, we need to make sure that this is set to precise click. Okay. One other thing that we'll have a look at doing as well is the button. If we have a look at the anchors here, what we had originally was we set the button to kind of fill the whole container here using the stretch to fill. Just make sure you change this to center anchor, and the reason that we're going to do that is because we want to make sure that the button itself it appears the correct size that we want when we set up our drag drop widget. I know it sounds a little bit cryptic at the minute, but trust me, when we get to it, you'll understand. Okay, so the next thing that we need to do, guys, is have a look at getting the actual drag drop functionality working. So we're going to jump over into the graph, and we're going to basically override some functions that are provided within the widget graph. So if I have a look over on the left hand side for functions, we're going to go to override, and what we want to have a look for is this one here, on preview mouse button down. Now there is a on mouse button down as well. What seems to have happened, and if you have a look on some of the documentation, in more recent versions of Unreal, they actually don't recommend using this button down here. They recommend using the on preview mouse button down. If you have a look at some of the tooltip there, you can see that what basically is happening here is that it's actually tunneling rather than bubbling. I'm not 100% sure what those terms mean, but basically using the on preview mouse button down allows you to kind of get this running. So we're going to say on preview mouse button down, and what we want to do is within this this function here, we want to detect drag if pressed. So we're going to hook in the execution between these and the return value into the return value, and the drag key that we're looking for is going to be the left mouse button, and we're just going to hook up the mouse event to the pointer event. So we can compile and save that. This function here basically is just looking to see, did we hold down the left mouse button and have we started dragging? So the next thing to have a look at after we've set up the actual mouse button event is to have a look at the function which will handle the dragging itself. So what we want to have a look for is the on drag detected event, which is here we go, on drag detected, and this will basically handle what happens when we're dragging the mouse. So what we'll want to do is we're going to create a new widget, and this is basically because when we click and drag our widget within our existing inventory, we want to have almost a preview of the widget that has the correct information in. So when you're clicking and dragging it from index 0 to index 4, as you're moving the mouse, you want to have that visual representation of what it is that you're actually dragging. So we're going to set the class to just be a slot widget blueprint, and to be able to feed in the information that we need, what we'll want to do is we'll want to actually set the values very similar to what we did in the actual inventory. So the return value, it's going to return the slot widget blueprint. So what we want to do is we want to set the item image. So set item image. Just move this over here. We'll also want to set item text. Nope, not that one. We'll want to, from here, set item text, and we'll also want to set current stack. So just hook up all the execution for these, and in terms of the item image itself, we're just going to hook in item image, because these values here will be set from the actual inventory itself. So we're going to hook these into here like so. There we go. And once that's done, we need to actually create the drag action itself. So we're just going to just type in create drag and drop operation. We're going to hook that up into there, and we can hook the return value into the operation. Now we have a default drag operation here. We're actually going to use our own drag and drop operation rather than using the default, because we want to be able to add some of our own variables as well. So what we'll do is we'll just minimize this for a second, and in the inventory content folder, we're just going to right click and create a new blueprint class, and we're just going to type in drag drop operation. So you can just type in drag and it'll be this option here. So select it and just give it a name. We'll just call it drag and drop, something like that. So open up this drag and drop, and there's not really going to be too much to do in here. All we're going to do basically is just add a variable, and we're going to call this slot dragged. Just make sure it's an integer, compile, and we want to make sure that this is public, and we also want to make sure that it is exposed on spawn as well. And what that basically means is, if you have a quick read of the tooltip there, you can see that should it be exposed as a pin when spawning this blueprint? Well, we want to say yes, because we want to be able to see this pin on the drag and drop operation node within the slot widget blueprint. So just compile that and save it, and if we just jump back over into slot widget blueprint, back into our on drag detected function, we can now go to the class and we can specify our drag and drop operation. Now what we'll want to do here is we just want to make sure that the slot dragged is just going to be the slot index from that we created way back in an older video. Just as a refresher for what this slot index is, I have actually renamed mine to slot index from slot clicked. In retrospect, I think slot clicked was a little bit ambiguous. Slot index, just to remind you what this is basically a publicly exposed variable which inside our inventory we can actually assign each of these slot array indexes. We can actually specify what number they are, and we use that to kind of specify where things are going to go. So that's kind of what that was if you were unsure. So we're specifying that the slot index is the slot dragged. What we want to do is we want to specify also that the slot widget created here is going to be the payload, and it's also going to be the drag visual as well. Okay. These are basically what we're passing through. So the payload is basically the object that you want to pass through. So we're passing through the widget. The reason that we're passing through the widget as a payload is that when we actually drop the widget, we can access the current values of that widget. The default drag visual is basically the widget to display when dragging the item. Normally people create a new widget to represent the temporary drag, as you can see there in the tooltip. That's what we've done here. We've created a temporary copy of this slot widget here. So I'm just going to tidy that up a little bit there. So that's basically what we're going to be able to see. The last thing really to have a look here is the pivot, and all this basically means is where do you want the widget to kind of snap to on your mouse cursor. If you leave it as center, what basically happens is it doesn't matter where you click on the widget button, the widget will kind of maneuver itself to center to where your mouse cursor is. We can just leave it as center, but if it bugs you a little bit, you can come back and change it in here. So just to test to see if this is actually working, our drag, we haven't done the drop yet, but we'll have a look at the drag and see if this is working. So let's just press compile, and let's just press save, and let's have a look and see if this is actually going to work. So if we test the game, let's just pick up an object. If we press E on our keyboard, I on our keyboard to open up the inventory, we should now be able to click and drag our widget, and you can see that we've got our widget is following us around. So that's great. And what's even better is you can see that the widget that is being dragged around has all of the correct information from the widget that we actually kind of initially dragged it from. So just to double check to make sure that's going to work with other objects as well. So if we get the ammo pack here as well, if we click and drag the ammo pack, you can see that that's working great. Okay, so the next thing to have a look at is how we're actually going to drop the picked up item within the inventory, and where we're actually going to drop it as well. So what we're going to have a look at doing first is just creating a function that will handle where things are going to drop. What's important to note here is that what we're actually doing when we move stuff around, we're not moving the image and dropping the image onto a new button. What we're actually doing behind the scenes is we're manipulating the data within the inventory array, the data array itself within the game instance. So with that in mind, we're going to jump into the game instance, and we're going to create a function inside the game instance which will handle moving around information within the inventory. So what we're going to do is create a new function which we'll call move item. and we're going to need a couple of additional variables to get this working. What we're going to have a look at is where we're moving the item from and where we're moving it to. So these are going to be array indices. So we're going to create these as variables. We're just going to do them as local variables, but we're going to create a variable called local from and another variable called local to. And these are both going to be integers because they're going to be basically references to indices within the inventory. So what we'll do is we're going to set our local from as the first variable to set, and let's just hook that into there, and we're going to set local to as well. Okay, and what we're going to set these values as? Well, what we're going to do is on the actual function itself, we're going to provide two inputs which we can feed into those variables because we're going to call this function later on. So we're going to call the first one from and the second one to, and we'll make both of these integers as well. So from goes into local from and to goes into local to. Okay, so we've got those variables done. What we want to firstly check is the widget that we're moving. When we drop it, are we dropping it on top of an item are we dropping it on top of a slot where we can actually drop it? We're not going to have a look in this video at kind of getting the stackable element to work in terms of combining stacks together if you drop a stackable item on top of another stackable item. We're not going to have a look at doing that. We just want to look firstly at moving widgets around within the inventory. But we need to double check that there isn't something already inside an inventory slot so that we can basically drop it on top of that slot. So what we'll need to do is we're going to get a reference to the inventory. So we can just hold down Control and drag inventory, and we're going to get. Now what we want to do is we want to check where we're dropping it. So we want to use the to variable, the local to variable here. And what we're going to check is if we break the item data, we want to check to make sure that the pickup type is not equal, so exclamation mark equals is not equal to none. I'm just going to run this into a conditional check. So basically what we're doing here is we're checking to see where we're going to drop the widget. Does that destination, the pickup type, is it not equal to none? And what we mean by not equal to none is, well, if it's not equal to none, then that means that it must be equal to something else, which means that that slot has a health pack or an ammo pack or coins inside that array index. So what we'll do to start with is we're going to run from the false branch. So if this fires back as false, then that means that that slot is set to none, which means that it's a slot where we can actually drop stuff into. So what we're going to do here is we're going to run from the false. We're going to run a set array elem node, and we're going to hook up the inventory as the target array, and the we're going to get from the array, get a reference, we're going to get a local from. So the local from is basically what information is in the index that we're dragging from. So we can feed that item into there. The index that we're going to actually feed it into is the local to. So we're moving the index from to the local to. And that's great, but if we just leave it as that, then what will happen is we'll essentially create a duplicate of this object, because it's not going to, this set array element doesn't kind of move, it doesn't move information between elements. We're just setting this particular index to be equal to this one. So what you would end up with is basically a duplicate of the original item. So to fix that, we're going to grab the set array again, just Control W to create a copy of that. And we need to feed in the inventory as the target array. And the index is going to be the local from, because we want to set the original index where we were pulling the information from. And in terms of the item, we're just going to do kind of what we did in the inventory blueprint. We're just going to create a make item data, and we're just going to leave everything as none. And that will basically reset that index to a none index. So once that's done from that branch, we can run this to a return node. So let's just right click and create a return node and just hook that up to there. And what we're going to do from the true branch is kind of similar to what we did here with the when we added an object and we kind of put a message up saying no free slots. We could do something quite similar here. We're just going to print a string, and all this is going to say, sorry, is that something like can't drop item here. There we go. So again, you could probably create this a little bit more fancy. You could have a nice little widget that pops up with a message saying can't drop the item here. I'm just going to stick with a print string for now, just whilst we debug. So just to kind of very quickly go through what we've done here, we've got a function which we will call later on, but we're feeding in from and to values. We're going to set these to local references to use within the function. And we firstly do a conditional check to say, is where we're dropping the widget actually available as a free slot? And we do that by comparing the item data in the destination slot to see if the pickup type is equal to none. If it is equal to none, that would fire off false, because we're checking that it is not equal to none, so that would fire off false. And what we do is we set the new index to have the item data that comes from the origin. So the local from is the origin, the local to is the destination. So we set the destination to have the item data from where it's coming from. After that, just as a fail-safe, because we don't want to duplicate the item, we set the original index to just have none as its item data, and just basically set all of the information in there to be sort of empty. What we run from the true branch here, so if our conditional check is the pickup type not equal to none, if that's true, then that basically means that we have an item in that slot. And if that is the case, then we're just going to print a message to the screen that says can't drop the item here. And as I mentioned before, you might want to make that a little bit more fancy. So we'll just compile that and save that, and that is pretty much done for the game instance, so we can close the game instance off. The next thing to have a look at is the actual drop functionality. The drop functionality is going to go back onto the slot widget. So this is going to be another overridden function. So if I have a look over on the left hand side, let's just go to override, and what we want to have a look at is the onDrop. So we're going to create onDrop, and what we want to do from the onDrop function entry point, we're going to look at the operation here, and the first thing we're going to do is we're just going to cast this to our drag and drop object. And the reason we want to do this is, if you remember back on the drag detected, this is where we basically, this operation, we feed in information here. What we fed into it is the slot index here. Now what we want to do is we want to set, we want to basically get the slot dragged, which is what we set here. The slot dragged is the slot index. So we're going to get the slot dragged, and we're going to use that to feed into our move item function. Now at the minute there's no way to call the move item function because we've created the move item function on the game instance. The reason being that this is where the inventory is actually saved, so it made sense to kind of do it here. One benefit of doing it in the game instance is that we can obviously get access to the game instance anywhere within our game. So on the slot widget blueprint, not inside the onDrop function, we're just going to go back to the event graph itself, and we're just going to run an event construct. So this is basically the same as begin play within your normal widget blueprints. So from event construct, we're going to say we want to cast to my game instance, and we're just going to get game instance from here, and from my game instance we'll promote this to a variable which we'll call game instance. There we go. So just compile that and jump back into the onDrop function, and if we now get our game instance, we can now call move item function. There we go. So the move item function, if you remember when we produced this, we gave it a from and to input. What we're going to do from the from is going to be the slot drag. So what is the origin of the widget that we are dragging? And the to is just going to be slot index. So we can hook that right up to there. Okay, so that move function, move item, will have everything fed into it that it needs. The last thing to do basically is just to refresh the inventory to make sure that all of the correct images appear on each of the buttons. So if we have a look in the inventory widget blueprint, remember we've got this refresh inventory here, which we can use to kind of loop through this. The only problem that we've got really is that there isn't really well, we need to get access to the inventory widget itself. Now, there's not really an easy way to do that within the slot widget blueprint. But if we think about this logically, where we've used the inventory widget blueprint, we've actually created the inventory widget blueprint on the first person character, because that's where we actually toggle the inventory widget blueprint itself. So remember way back when we created, when we were first looking at actually getting the widget blueprint to open and toggle through, we have to create a reference to it here. What we can actually do inside the slot widget blueprint is we can get the reference from the first person character and promote it to its own variable inside the slot. So we're going to go to the event graph for the slot widget blueprint, and on the event construct, after we've done the game instance, we're going to cast to first person character, and we'll need to get player character. And as first person character, we can actually get the inventory widget through here. So it's almost like we're going to reference a reference of another object, which sounds a bit clunky, but it works perfectly fine. So we're going to promote this to its own variable, which we'll call, just to call it inventory. And we need to execute that as well. And if we compile that, we can now get access to anything that is included within the inventory widget blueprint. In this case, the refresh inventory event. So inside the onDrop function, we can now get our inventory here, and we can call refresh inventory. So we can hook that up to there, and hook that up to there, and compile, and save. And let's give this a test now to see if this is going to work. So we're going to hit play. Let's pick up some items. Press letter I on our keyboard, and we should now be able to click and drag these and drop them to different slots. And you can see that that is working perfectly. There we go. Excellent. What you'll notice with the precise click now is that clicking your buttons doesn't actually work. What you now have to do is a double click just to get to the use menu. But you can see that everything still works perfectly fine. Our toss and use functionality is working exactly as expected. So if I want to toss this item, I can toss it and it gets rid of it. Let's try picking up some stackable items as well and seeing how this works. There we go. So we've got our stackable item and our non-stackable item. We can click and drag the non-stackable items and stackable items around, and everything works as expected. So building upon the original functionality that we had, you can see that everything is working perfectly fine. There we go. So we can reload still, we can heal, and everything is working exactly as expected. So we'll wrap up the video there, but just to kind of recap what we've kind of looked at within this video, we've had to tweak a couple of elements of functionality for how the array gets calculated. So we started by just having a look at the inventory itself and setting the actual maximum amount of values here. We created inside the inventory widget blueprint, we modified the functionality of looping through the visual and data arrays, and rather than comparing values, we just basically say, look at this inventory slot, figure out what information's in it and set it, and then do it to the next one and the next one and the next one. So we're not comparing anything, we're just looking through all indices within the array. We had to change some of the functionality here for when we tossed and used items. Rather than removing from index, we're setting the used index back to none, which is what we set up on our enumerator. And we had a look at playing around with the adding to inventory structure as functionality as well. So rather than just adding an index, we firstly need to check for a free slot, and that's just done with a simple for each loop with break. We got that return node there. We have a look through the entire array, our data array, and we find the first index that is free, and we set that to be our new index to add our item to. In fact, just to double check that, we didn't actually test that functionality there. So let's just quickly check to see what happens if we try to pick up more items than we can hold. So let's see, that's 4, that's 5, so this should be the last one, that's 6. So let's try and pick up this coin. You can see that no matter how many times I try, it's not adding to the inventory, it's not deleting from the scene, and we're actually getting a nice message in the top left corner, no free slots in the inventory. So that's working perfectly fine as well. If we could jump into the inventory, you can see that we've got our objects here. If we remove one from this bit here, when we go back into the game, if we try and add that, that will now add to the first free index slot. So that's working perfectly fine as well. So thanks for watching that bonus video, guys, on setting up or tweaking the original array to encompass drag and drop and reordering your inventories. What we'll probably have a look at in a further bonus video is when we toss items, how can we get a new representation to appear within the scene. But yeah, thanks a lot for watching, guys. Keep an eye out for that next video.